Okay, hello everybody. It's great to see you once again. This is the second video of lesson 11.3. Hopefully yesterday's homework didn't give you any problems. You understood it well enough. Today we're going to finish up lesson 11.3 with problems 3 and 4. Once again, before we get started, I want to encourage you to use this video effectively. Pause it during times that's appropriate to pause when it comes to the got it problems or whatever. If you get confused about something, you need to hear me re-explain it, rewind it, go back to when I did the problems, go back to when I did the problems, rewatch it if you need. Use this effectively. Okay, don't just skip through it and not watch it and think you're going to be okay. Use this as a way to practice. Okay. Also, I do again want to mention that my email, if you need to get a hold of me at all today, next week, whenever, joyoder@bps.k12.in.us. I don't know how busy I'll be over the next couple weeks, but I'm going to try and keep my phone on me so I can see if you're trying to email me, ask me any questions about any homework or whatever. Feel free to let me know. Also, if the volume of the video is a little low, you might be able to turn up the volume. Hopefully you'll be able to hear my voice well enough. Okay. All right. So let's go ahead and get started with 11.3 part 2. And we're going to get into problem 3, dividing polynomials with a zero coefficient. Okay, so if we look at the problem, it says the width W of a rectangle is 3z minus 1. The area A of the rectangle is 18z cubed minus 8z plus 2. Now wants to know, what is an expression for the length of the rectangle? Okay, if you remember, we're talking about area of a rectangle. Area of a rectangle is simply length times width. Okay, now remember, it's difficult for me to write with a mouse, so my handwriting is going to be pretty sloppy, but I'll try my best to be as neat as I can. So area is equal to length times width. We're given the area, right? That's this 18z cubed minus 8z plus 2. We are given the width as well. The width is 3z minus 1. And then we're missing the length. So we want to solve for the length of this rectangle. So to do that, all we have to do is divide by W on both sides. So an expression for the length, we can use just the area divided by the width. So the area, you're going to do 18z cubed minus 8z plus 2. And divide by the width, 3z minus 1. Okay? Now there's one way that we got to do something in order to be able to do this. If you look at this trinomial for the area, 18z cubed minus 8z plus 2, there's something missing, and that's the z squared term. It's got z cubed, we're missing the z squared, we've got the z, and then we've got the constant. So what we need to do is we need to add in the z squared, but we're going to put a zero coefficient in front of it. That way it doesn't change the expression at all. All it does is adds in the z squared so that we can divide it properly. Okay? All right, so this is going to show you how to set this up. We want to have the set it up so that we have 18z cubed plus the 0z squared that we're adding in minus 8z plus 2, and then the outside 3z minus 1. Okay? So again, what we want to do is we want to take the first term, and we're going to look at the first two terms of the polynomial here. We want to see how many times 3z goes into 18z cubed. Okay, so we know it goes in 3 goes into 18 6 times, and z goes into z cubed z squared times. So I'm going to put the 6z squared above the second term right here. Okay, so then I'm going to multiply. I'm going to distribute 6z squared times 3z is 18z cubed. 6z squared times negative 1 is negative 6z squared. And then we're going to subtract these. So 18z cubed minus 18z cubed, that's 0. 0z squared minus a negative 6z squared. Remember, minus a negative is the same as adding a positive. So that becomes a positive 6z squared. And then we're going to drop down our next term, negative 8z. Now I want to see how many times 3z goes into 6z squared. Okay, 3 goes into 6 twice, z goes into z squared, z times. So the next term we're going to add is 2z up here. Now we're going to distribute again. 2z times 3z is 6z squared. 2z times negative 1 is negative 2z. And now we want to subtract. These cancel out. Negative 8z minus a negative 2z, same as plus a positive 2z, so negative 8z plus 2z is negative 6z, and then drop down our 2. And now we're going to see how many times 3z goes into negative 6z. 3 goes into negative 6, negative 2 times, and then z goes into z 1 time. So the next term we're going to add is minus 2. So now we're going to distribute again to wrap it up. Negative 2 times 3z is negative 6z. Negative 2 times negative 1 is a positive 2. And then if we subtract negative 6z plus 2 minus negative 6z plus 2, we get a remainder of 0. So we are going to stop here. And our solution, the length of the rectangle, is 6z squared plus 2z minus 2. Okay? All right, so if that makes sense, you can move on to the got it. If you need to rewatch it, feel free to rewind it. Rewatch the whole thing if you need to. Okay? All right, so go ahead and try these got it problems. Set it up just like I showed you. So in part A here, you're missing the q cubed term, so you want to add in 0q cubed before you divide. For part B, you're missing the h squared, so you want to add that in before you divide. So go ahead and do that now. Pause the video and practice them, and then I'll see you here in a second. Okay, so hopefully you had a chance to actually work these problems out. I'm going to write this out, q minus 1. Actually, I'm going to make this a little bit smaller because I have a feeling I'm going to run out of some room. So I'm going to do q minus 1, and then divided by, or on the inside, it's going to be q to the 4th, plus, I got to add in my q cubed, so 0q cubed, and then I can add the q squared plus q minus 3. Okay? Now again, I want to see how many times q goes into q to the 4th. And I'm going to put that term right above the second term, the 0q cubed term. So that is q cubed. Now I'll distribute. Q cubed times q is q to the 4th. Q cubed times negative 1 is negative q cubed. And now we want to subtract. Q to the 4th minus q to the 4th is 0. 0q cubed minus a negative q cubed. Remember, when you minus a negative, you got to add it. So 0 plus 1q cubed is going to be 1q cubed. And now we're going to drop down our next term, plus q squared. Now we want to figure out how many times q goes into q cubed. That's q squared. So I'm going to do plus q squared. And now distribute. Q squared times q is q cubed. Q squared times negative 1 is negative q squared. And now once again, I want to subtract. These cancel out. Q squared minus negative q squared. This is 1q squared minus negative 1q squared, which is going to be plus a positive q squared. So it's 2q squared plus q after I drop this down. Now how many times does q go into 2q squared? Well, that's 2q. So I'm going to add 2q right up here. Now we distribute. 2q times q is 2q squared. 2q times negative 1 is negative 2q. And now once again I'll subtract. These cancel out. 1q minus negative 2q is going to be a positive 3q. Gosh, I'm running out of space here. That looks like a 39. But that's 3q. And then minus 3. Gosh, my dog's going crazy back here. He's got to go to the bathroom. So I'm going to try and go through this quickly so I can let him out. All right, so now I've got 3q minus 3. We want to see how many times q goes into 3q. Well, that's a positive 3 times. So 3 times q is 3q. 3 times negative 1 is negative 3. So I got 3q minus 3. And then minus 3q minus 3, we get a remainder of 0. So your solution for this is q cubed plus q squared plus 2q plus 3. So that one was kind of tricky. You got to make sure you remember that when you subtract a negative, it's the same as adding a positive. Okay, our solution for b, I'm not going to go through the whole thing, but our solution for b should be h squared minus 3h, that's a terrible h, plus 5 minus 3, there's going to be a remainder at the end, 3 over h plus 3. Okay? So if you need to redo or retry any of those, feel free to go back. I'm going to move on to problem 4. Okay? This is reordering terms and dividing polynomials. One thing you got to make sure you do when you're dividing polynomials is you want to make sure that you write the divisor and the dividend in standard form. If you remember standard form, that's where you got to make sure that the variables, the highest exponent goes first, and then you go down in descending order. So this says, what is negative 10x minus 1 plus 4x squared divided by negative 3 plus 2x? You want to rewrite them in standard form first. So the trinomial here written in standard form is 4x squared minus 10x minus 1. And then the binomial written in standard form is 2x minus 3. Okay? Now we're just going to divide it like we did before. How many times does 2x go into 4x squared? Well, that's 2x times. Actually, I just realized I've got this whole problem worked out on the next slide here. So 2x goes into 4x, 2x times. Multiply them out, you get 4x squared minus 6x. Subtract, these cancel out. Negative 10x minus 6x is the same as plus a positive, so that becomes a negative 4x. Drop down the negative 1. How many times does 2x go into negative 4x? That's negative 2 times. Then you'll distribute again. Negative 2 times 2x minus 3. It's going to give you negative 4x plus 6. These cancel out when we subtract. Negative 1 minus 6 is negative 7. So that means we're going to have a remainder in this problem. You're going to start with your 2x minus 2 right here. But then you're going to subtract 7 over your first part right here, your binomial. So your remainder is going to be negative 7 over 2x minus 3. So your answer here is going to be B. 2x minus 2 minus 7 over 2x minus 3. So you got to make sure you remember before you divide, put it into standard form first. All right, go ahead and try these. Got it. Put them into standard form first and then divide. All right, so if you did this correctly, if you set this up correctly, you're going to have your division sign here. And then on the outside, you're going to have 3y plus 4. On the inside, you want 6y squared minus 10y minus 7. Okay? Now these problems are just like ones we did before. You got to figure out how many times 3y goes into 6y. Okay? So we've practiced this a couple times. I'm not going to go through the whole problem just to save a little time. Okay? The solution to this, you should have 2y minus 19 over 3 plus 55 over 3 times 3y plus 4. Okay? Your solution for part B, you should have had 3a plus 1 minus 3 over 6a plus 5. Okay? So you got remainders in both these at the end. Your remainder should have been 55 over 3 for the last term, and then you got to put that over the 3y plus 4. So the 3y plus 4 just goes on the bottom of the fraction. Over here, again, we have a remainder of negative 3, so you put that over the 6a plus 5. Okay? All right, so those are the two problems. There's one more slide here. I would suggest it might be helpful to write this maybe in your notebook so you remember all the steps to dividing a polynomial by a polynomial. Step 1 is to arrange the terms of the dividend and divisor in standard form. Okay? If a term's missing from the dividend, make sure you add it with a coefficient of 0. You don't want to leave it out, so add that in there. Step 2 is where the long division process takes place. So divide the first term of the dividend by the first term of the divisor. This is going to be the first term of the quotient. Step 3, multiply the first term of the quotient by the whole divisor and place the product under the dividend. Then subtract this product from the dividend, bring down the next term, okay, and then repeat steps 2 through 5 as necessary until you get to the very end with any remainders. If you have a remainder, put it over that binomial that you're dividing by. Okay? Again, if you have questions, feel free to email me. Feel free to talk to your sub. She probably has the answer key to some stuff that you can ask her to check any answers that you might have or any questions. But yeah, if you have questions, just email me, let me know, and I'll try and answer. Have a great weekend. We'll see you guys in a couple weeks. Good luck on ICEP review next week, and good luck on iLearn review, and good luck on at the start of iLearn. I'll be back towards the end of iLearn during that week. Okay. All right. See you guys. Have a great weekend. Bye.